Hi, I'm Steve Halladay, and in this video I'm going to show you how to control the servo with your MotorShield. The servos are the easiest motors to control because they don't require any libraries beyond the standard libraries that Arduino comes with. So let's get started. First off, let's make sure that we've got our servos connected up correctly. You may remember this image from a previous video. We're showing how the MotorShield is wired up, but specifically in this video we're interested in the servo pins up here. These three pins control servo 1 and these three pins control servo 2. The pin on the left in both of these servo 1 and servo 2 pin set connects to the brown wire, which is the ground wire, so it's basically just a ground. The pin in the middle on both servos is the red wire, which is the power, so this is connected to a 5-volt power supply. And then the pin on the far right for servo 1 and for servo 2 is the control pin. Servo 1 has a different control pin than servo 2. For servo 1, the control pin is actually one of the digital pins. It's pin 10. I've covered it up with the black line here so it's a little bit hard to see. But this digital pin is also presented here for servo 1. For servo 2, the control pin is actually pin 9, digital pin 9. So what you'll do is hook up your servo to the pins here on servo 1. Remember to have the brown wire in this location, the red wire here, and the orange wire here. And when we do this, we'll control servo 1 with pin 10, and we'll control servo 2 with pin 9. Let's take a look at how we can write some software to control the Arduino. You can see here that I've opened the Arduino app, which is the IDE for creating software for the Arduino. And I've created these two methods in this app, the setup method and the loop method. We talked about these previously. These are the two methods that you must write to be able to create a sketch or an app for Arduino. The setup method gets called once at the beginning, and then the loop method gets called over and over repetitively. So this is the simplest app I can create. It's an app with these two methods that do nothing. Now, just to make sure that we're typing everything in the way we ought to, we can try and compile this at this time, make sure we don't get any syntax errors. A syntax error might happen, for example, if I misspelled setup or loop or something like that. So we look down here and we see, no, there were no syntax errors. So far, so good. So what do we need to do? Well, the first thing we need to do is create a data item that will allow us to control the servo. This data item is of type servo. We'll call it servo 1. Now, this word right here tells us what kind of a variable we are creating, and this is the name of the variable here. So this word we have to spell exactly as is, and it's case sensitive, so it has to be a capital S. And this word we can use whatever we want. It's just the name of what we're going to call this servo, or this software item that controls the servo. I could have called it Fred. I called it servo 1. Let's try and compile this and see what happens. We see that we get a syntax error that says servo does not name a type. Well, why could that be? Well, it turns out that we haven't included anything that tells us what servo is, and we need to do that before we can actually use the servo. And the way we include something is we'll do it like this. Once again, case is important here. Include capital S servo.h. Okay. What this does is this includes this file servo.h from the Arduino library files, and it's as if I had actually typed the contents of this file into the file that I'm working on here right at this point. So let's try it again. So now we see that we didn't get a syntax error and that servo.h defines what servo is. So now we're ready to go. So the first thing that we can do then is we can attach this servo to a specific pin on the Arduino. And the way we do that is by calling the servo's attach method. And we'll attach it to pin number 10 here. That would be the outer of the two pin controllers on the MotorShield. We can compile this, and sure enough, no syntax errors. So far we're good to go on this. Now, how did I know that I could call this attach method? Well, the way I figure that out is by looking at the Arduino library documentation. Here is the web page that contains the table of contents for all the standard libraries associated with Arduino. We see if we look down here, these are libraries for controlling specific types of hardware, and here's the servo library here. So we'll click on this link and it takes us over to this section that describes the servo library. We see on the right over here the methods that we can call associated with the servo. We already saw how we called the attach method, but if we want to see the details on that, we click into the attach method here and we can see the description here. It talks about the two ways we can call it. We can call it with either just the pin number or a pin and a min and a max. The parameters get described here. The pin number is the pin that the servo is attached to. And remember, our choices there are 9 or 10. And then the pulse width has to do with the minimum pulse width and maximum pulse width has to do with controlling the servo. And to be honest with you, I'm not sure what all that means. I'm not that deep into it to where I would understand it. And then there's a small example here of how to call it. And you'll notice this is basically the code that we typed in, it turns out. So that's how we can look at that. Now if we go back to look at the other methods we can call on the servo, we notice there's a read and a write method and then some other stuff, attached and detached. Attached just tells us if we did attach to the servo already. We know that we did, so we won't need to call that. But this write method is kind of interesting. If we look at this, the way it works is we write and we give it an angle, and this angle can be from 0 to 180. So if we write a 0 into it, it's going to move the servo all the way counterclockwise one direction, and if we write a 180 in it, it's going to move it clockwise all the way to the other direction that the servo can go. And you can see here's an example. They attach to pin 9 and then they write it to 90, which is right in the middle. So let's take a look and see if we can figure out how to do that. Back to the Arduino app, back to our sketch that we started. Let's try and write to the servo and see if we can make the servo move. We can do that by using this servo1 variable again, and we'll say write. And let's first of all write it back to the beginning of its location. We'll write to position 0. And then we saw in our blink example in a previous video that we can delay by specifying how many milliseconds we want to delay for. So we'll wait for a second. And the servo is only interesting to look at if it moves. So let's put it into a different position here. We'll move to position 180. There. And let's delay again in that position because remember this is going to be called in a loop. So let's delay for a second here. And we ought to be good to go. Let's try downloading that. And here's what it looks like when it runs. We notice that it moves back and forth between the two positions with a little bit of delay in between. So there you have it, everything you need to know about controlling the servos. If I wanted to control a second servo, I could attach that to pin 9 and write to that servo. I could call it servo 2 in my code or whatever. Remember, if you're interested in following along with these videos, you can get all the parts that you need, including both servos, in one kit at swarmus.com. I look forward to working with you in the next video where we'll work on controlling the DC motors.